Imagine Earth's continents not as static land masses but as massive ships sailing across a vast rocky ocean. Beneath the surface, a hidden mechanism is at work. What exactly is guiding their long-term course through geological time? For over 4 billion years, a fascinating pattern has emerged. This isn't just a coincidence of plate tectonics. It is a governed movement dictated by the fundamental physics of a spinning sphere. To understand why, we must look at the mechanical forces steering our planet. Earth is tilted by about 23.5. We learned that number in school because it explains seasons. But today, I want to ask a different question. What if that tilt didn't just change sunlight? What if it also nudged how our planet moved, cooled, and organized itself long before the continents looked anything like they do now? Earth was a lava ocean. No land, no water, just 2,000 sea rock soup. The oldest pieces of land formed inside that soup. 4.5 billion years ago, Earth was molten from impacts. As it cooled, crystals floated to the top like scum on soup. That scum became the first crust. Most of it got recycled back in, but some chunks were so thick and cold they never melted again. We call those Cratons. 300 kilometers deep, keels older than 2.5 billion years. Canada sits on one. So does Australia, Brazil, and Europa. They're too thick to break. So, mantle must flow around them. Think of them as rocks in a river. The river equals mantle flow. The rocks don't move. They steer the river. Remember, the core spins faster than the mantle. That shear is the engine. It drives mantle to flow up to the surface. When that flow hits a 300 kilometers Craton keel, it can't go through. It deflects. That deflection is where new oceans open and mountains form. My initial question about mountain belt directions revealed significant inconsistencies. It made me question the standard tectonic narrative we've all been taught. Why do major mountain systems localize near Craton edges and ancient boundaries? Why don't they form uniformly across continental plates? How much of continental shape is controlled by inherited deep structures rather than solely by later plate motion? How does the opening of the South Atlantic relate to Andean mountain building, especially if their timelines don't align as current models suggest? What is the true role of mantle plumes in continental breakup and volcanic activity, and in the long-term reorganization of our continents? If plume-related breakup opens oceans, what determines the resulting geological phenomena? Why does the simplified tectonic story often feel incomplete when considering Cratons' plume activity and inherited continental structure? Could the deepest organizing features of continents have formed under much earlier Earth conditions far different than typically emphasized in standard plate tectonics? Geology, like all science, has many discrepancies that don't simply disappear. They reveal a larger truth. Reality is often richer and more structured than the simplest explanations allow. If you're interested in exploring these inconsistencies further, join me. Explore my channel for additional videos on these unresolved geological questions.